Do you know what insect I am most afraid of? Is it a cockroach? No, it's the earthworm. Why is that? Because of its cemented body. If it cements one by one, it looks very disgusting.
Well, about that, did you know that aside from segmentation in worms, there's also a topic about segmentation in our operating system, which is about address translation and simple segmentation.
Oh, actually I didn't know about that. Can you explain it to me?
Yeah, sure. In operating system, segmentation is a memory management technique where the memory is divided into variable size parts, which are called segments. Segments can be allocated to a process. In a segment table, there's mainly two information, which is the base address and the length of the segment.
That sounds pretty big. Can you use some vivid examples so that you can explain to me so that I can understand it better?
Sure, let's watch a video demonstrating it.
Let's say in a library there's someone who wants to borrow a book. The customer can be set as a user while librarian as a CPU. Librarian will get input from customer to detect where the located address of the book. Each book shelf itself is like a segment in memory that categorizes the book. Librarian will go through each shelf that allocates the data to retrieve them for the customer. The book will then be processed before being sent to user.
Oh, okay. I think I roughly understand it now. But why do we need to use it?
The operating system doesn't care about the user's views. It may divide different programs into different pages, and some pages may or may not load. This causes inefficiency in the system. It's better to have segmentation in an operating system so that the parts can be divided equally. It is better to have segmentation so that each process would be divided into different segments. Each segment will contain the same type of functions. Otherwise, paging would take forever to load. Hence, segmentation was introduced to divide a code into many modules and combine any related code into one single block. Segmentation overcomes one of the problems by dividing the tasks into any specific need.
It sounds like it has a lot of benefits.
It is easy to relocate a single segment rather than an entire address. There's also no internal fragmentation and less overhead. But there's also some drawbacks. First, it could have external fragmentation. Second, trying to allocate the contiguous memory is quite hard. Third, it's quite costly towards the memory management algorithm.
Let's see a video on how the calculations work. Alright.
Hey guys, today we are going to learn about address translation in simple segmentation. There are four keywords that you all need to remember, which is E, F, C, S. Extra, find, compare, and sum. E. Extra. The segment number as the leftmost n bit of the logical address. Just as the example below. This is a 16-bit logical address, and the leftmost 4-bit segment, which is 0001, is the segment. So we need to extract it. And what is the logical address? So, logical address is an address generated by the CPU during a program execution. F. Use the segment number as an index into the process segment table to find the starting physical address of the segment. So, this is the physical address, where is the actual location in the computer physical memory. We call it RAM, where data is stored. You can refer to the process segment table and get the starting physical address where it's circled. C. Compare. Compare the offset expressed in the rightmost n bits to the length of the segment. If the offset is greater than or equal to the length, the address is invalid. So in this case, we can calculate the offset number and get the total, which is 752. Since the maximum segment size is more than the offset number, so this address is valid. S. Sum. The desired physical address is the sum of the starting physical address of the segment plus the offset. Here is the calculation, and we can get the desired physical address. So that's all for me. I hope you all can enjoy learning with me. We see you in the next video. Bye!